All right, so today we're going to look at how we balance equations. And so we've been looking at it a little bit in some little introductory activities. If we look here at our picture, this is showing us what's happening. We've got H2, which is what?
We've got two H's.
We've got two H's, and we've got O2, which is?
Two O's.
And this is going to make us what?
Two H's and one O.
And what do we call H2O?
Water.
Water. But if we look at our picture down here, what do we notice has happened? We start off with our two H's, and we start off with our two O's, and we get two H's and one O. What happened to our other O?
I don't know.
I don't know. It went away. Do we think atoms can just go away?
I would assume not.
Yeah, because that was actually one of the things we still agree with on Dalton. He said that we have to keep all of our atoms. This, by the way, is our law of conservation of mass.
Right, atoms cannot be created or destroyed.
Right, so you've got it, whatever atoms you start with, you have to end up with. Here we're starting with two H's and two O's, and we only get one O. So this is a problem.
Yes.
So what do you think we need to do?
I guess we probably need some more O's.
We need some more.
H's.
Well, yeah, we need some more O's, and then we'll probably need some more H's. So if we look here, what we can add to make it balanced, so that we have the same number of atoms on each side, are what's called coefficients. And you should know that word from algebra. Remember what coefficients were?
Coefficients.
All right.
Big numbers.
Big numbers. Those are our numbers in front. So anytime I like if I had 4x, that's a coefficient, or 4 is. All right. So if we look here, we've got H2, and O2 gives us H2O. What we want to do is take what's called an atom inventory. And an atom inventory, do you know what an inventory is?
It's a list of everything you have.
It's a list of everything we have. So it's really useful if we're trying to make sure we've got enough of everything on both sides. They have an atom inventory. And when I teach this, I always tell my kids to wrap. So what do we call the left-hand side of our reaction?
The reactants.
And the right-hand side is our
products.
And so down the middle, we're going to list our atoms.
Atoms.
All right, so what atoms do we have on the reactant side?
I have H's.
Okay, and we have?
O's.
Do I have any other atoms on my product side that I didn't have on my reactant side?
Nope.
Should I?
No.
No, because they can't change. All right, so how many H's do I have on my reactant side?
2.
How many O's do I have?
2.
Product side, how many H's do I have?
2.
Oxygens?
1.
1. All right, so what do we say doesn't match?
O's.
O's. So now, all I can add are coefficients, and those are big numbers in front.
Big numbers in front.
So how many H2O's do I need if I need 2 O's?
Okay, well, if I need another O, I'm going to have to put 2 on it.
Right, because we need a total of 2 O's. So if each has 1, 2 H2O's gives us 2 O's. But what does that do to our H's?
Okay, well, now I would have 4 H's, though, right? Because it's like math.
Mm-hmm.
Where 2 times 2 is 4.
There you go. So now, this is our product side. What's wrong now?
Okay, well, now I don't have enough H's on the reactant side.
But how can I fix that?
Well, we could put a 2 in front of the H2.
And if I put a 2 in front of the H2, how many H's does that give me on my reactant
2
side?
times 2 is 4.
Does everything match?
And now we match.
We now have a balanced equation.
Yay!
All right. So let's look at another example. We're not going to show the pictures this time. We're just going to look at our letters.
Okay.
What did we need to do first? What do we call our list at the bottom? We got to wrap.
Gotta wrap.
Got to wrap and do our atom inventory. All right. So we start by listing our atoms. What are our atoms that we have in this reaction?
N and H.
N and H, because we're taking NH3, which is ammonia, and decomposing it into nitrogen gas and hydrogen gas. How many N's do I have on my reactant side?
1.
1. H's.
3.
Product side, what do I have?
2.
And then
2.
2. All right. So what doesn't match?
None of them.
None of them match. What do we think is easier to fix?
The N's.
The N's. Because I've got 2 here and 1 here. And if I've got a 2 on the product side and a 1 on my reactant side, what do I need on my reactant side?
2.
2. So if I now have two NH3s, how many N's does that give me?
2.
How many H's does that give me?
Well, I got a 2 in front, but H has a 3, so I'm multiplying.
We're gonna-
That's 6.
That's going to be 6. Okay? So now my N's are okay, but
Yeah.
my H's aren't. So what do I need to do with my H's?
Well, I've got a 2 down there, so I need something that when I multiply it, it's going to be 6.
Mm-hmm.
So 2 times 3 is 6, so we can put 3.
Mm-hmm. And now we've got 6. And
There we
so
go.
now everything matches.
Yay.
All right. Now we're going to do something a little bit more complicated. Only a little bit, though. So here I have AgNO3. What did we call NO3?
That's a polyatomic.
It's a polyatomic ion. And we're adding that to copper. And we're getting copper with our polyatomic ion, that's nitrate, by the way, and silver. The nice thing is, did anything happen to my NO3?
It's still NO3 on both sides.
It's still NO3 on both sides. If you have a polyatomic that stays the same on both sides, you can actually treat it like one atom. And it'll make your life way easier.
Yeah.
All right, so what do we need to do first?
Wrap.
We got to wrap. We would wrap for you. It would be bad. All right, so we're going to wrap. All right, so our first atom is
Ag.
Ag, and then we said NO3 could just be an atom.
1, yes.
So we're going to treat that like one atom. And then what's the only other atom we've
Cu.
got? Cu. All right, so how many Ags do I have?
1.
How many NO3s do I have?
1.
1. But there's a 3 there.
But that's part of the polyatomic.
It's part of the polyatomic. Do not tell me you've got 3 NO3s. So that's 1. All right, and how many coppers do I have?
1.
All right, on my product side, how many Ags do I have?
1.
How many NO3s do I have?
That one has got a 2 outside.
That one's got a 2 outside the parentheses, so I've got 2 of all of that together. And then how many coppers do I have?
1.
1. All right, so what doesn't match?
The NO3s.
The NO3s. And so what do I need to do? Which side do I need to fix?
The reactant.
The reactant. And what do I need to add to my reactant side?
I need 2.
We need 2 what?
NO3s.
NO3s, so I got to put 2 in front of my AgNO3. Do not try to change parts within it. The whole thing has to change.
Yeah, I can't stick it just in the middle, right? It's got to go in front of everything.
Right.
Okay.
All right. So we've got 2 NO3s, but what else have we changed?
Well, change the Ag.
Change the Ag. So how many Ags do I have
2.
now? 2. And so if I've got 2 Ags,
So I got to put 2 on the other side, on the
I gotta
product
put
side.
2 on the other side. So does everything match now?
Now it matches.
Now it all matches. That's how we balance if we've got polyatomic. See, they don't make anything any scarier, do they?
Nah.
No. All right.